Alright, so you've done a lot of different factoring practices the last few days, hopefully. And if you look at some of the ones in the textbook, you'll see there's a couple of different ones out there. Ones that didn't necessarily seem to fit well into the categories we saw last lesson, which is, simple trinomials, complex trinomials, difference of squares, perfect square trinomials. So it's good to look at a few of these and see that they're actually not as bad as we think, that most of the time they work with arrays or using some other method. So looking at this first one here, this one definitely looks different, mainly because it's not a trinomial. Okay, there's actually 4 terms in it. And we did ones like this, or similar to it, way back in the first lesson this unit on common factoring, but it's been a little while. What you'll notice here is we have 4 terms, and you're always going to start by looking for a greatest common factor. We don't see any greatest common factors here. So what we're actually going to try, and you may remember, again, doing this back in lesson 22, I believe it was, on common factoring, is factoring by grouping. So if we're going to factor by grouping, we're going to take a look at 2 different groups of terms in the equation. So we're going to take a look at the first 2 together first, and we're going to common factor them. So looking at x cubed and 4x squared, we're just going to look at those 2 to find a common factor. So those 2 both have an x squared in common. And if I take out the x squared, I'm going to be left with x plus 4 left over. Okay, now I'm going to look at the next 2 terms. So I have minus 9x and minus 36. So both 9x and 36 are divisible by 9. So I'll take out the 9 with that negative as well. So I'll take out minus 9 and be left with x plus 4. Now, again, reason being that this x plus 4 is it was minus 36 by a factor of negative 9, so the signs inside change. Now, if grouping is to work, it doesn't always work, but if grouping is to work, then what I'm going to see here is actually have a common factor of x plus 4. Now, sometimes it's going to be a little trickier to see, but I really do have 2 big terms here. I have x squared times x plus 4, and I have minus 9 times x plus 4. So what do both of these terms have in common? It is the x plus 4. So that is now going to be my common factor. So x plus 4 gets taken out, and I have x squared minus 9 left over. Okay, so with this grouping here, I was able to take this into something that looks a lot more factored than what it was before. Now, it's very tempting to think that I'm done here. However, if you're not careful, you'll see that you can actually, if you're not careful, you'll miss the fact that x squared minus 9 here can actually factor further. This is a difference of squares pattern right here. So I'm going to leave the x plus 4 alone, but the x squared minus 9 factors into x minus 3, x plus 3. Okay, so, and if you don't see that difference of squares pattern, remember we could always still do it in an array. I'll take the x squared, put it in here, the minus 9, so I'd be looking for 2 numbers that multiply to negative 9 and add to 0. So those 2 numbers are going to be 3 and negative 3. Okay, so you'll see once I do that how this factors into x plus 3, x minus 3. But do try and get used to recognizing the difference of squares pattern because it can save you a lot of time. So now I've taken this as far as it can go, and this is my fully factored form. Okay, let's look at a couple other ones here. So I'm looking at t to the exponent 4 minus 16. Now, if you recognize this one as being 2 perfect squares, t to the exponent 4 is a perfect square, t squared times t squared, and 16 is a perfect square, 4 times 4. I can jump straight into this being a difference of squares pattern and say this is t squared minus 4 and t squared plus 4. Okay, if I did not see that pattern, I still could have gotten it by throwing it into an array. I have t to the exponent 4 here, minus 16 here. So if I was going to try something that multiplied that to t to the 4th, I'd have t squared and t squared. So we're looking for 2 numbers that multiply to negative 16, add to 0, it's going to be 4 and negative 4. However, my middle term would be t squared here because I'm going to have 4 times t squared here. So I'm going to get t squared and t squared here. So I get t squared minus 4, t squared plus 4. Okay, and this is an excellent start. Once again, we should always try to see if this factors any further. So t squared minus 4 you'll recognize as a difference of squares. Okay, so which numbers multiply to negative 4, add to 0? Well, it's going to be 2 and minus 2. So the t squared minus 4 here factors into t minus 2, t plus 2. Okay, and I'm left to deal with this t squared plus 4. So if I take a look here and I even try to factor this one, okay, so that's again trying to do this one down here, you'll see I'd be looking for two numbers that multiply to positive 4 and add to 0. And you can see pretty quickly this is going to be impossible. So in order for two numbers to multiply to a positive, they would have to be both positive or both negative. Well, if they both have the same sign, they can't add to 0, right? They're either going to add to a positive or a negative answer. So this does not factor any further. So the t squared minus 4 will just have to stay as it is. Okay, so let's take a look at C. So what makes this one look a bit more complicated than some of the other ones is the presence of having both x and y variables in there. But when in doubt, you just want to try and throw it in an array and just see what happens, right? So when in doubt, array it out. So I'm going to put x squared up here, minus 12y squared down here. And you know if you have x squared here, the only things that can multiply that are x and x. So let's try and take the same approach we did before. What multiplies to negative 12 and adds to negative 4? And those two numbers are going to be negative 6 and 2. But my middle term here has x's and y, so I'm going to have minus 6xy and 2xy. Now, just to be a little bit more careful here, if I have x, I'm trying to multiply by something to get negative 6y, well, it's not going to just be negative 6, it's going to be negative 6y. That's how I'm going to get the y term here. So here, x times what gives me 2xy? It's going to be 2y. And you'll see that's how I get my y squared down here. So I multiply these blue terms together, negative 6y times 2y, I get negative 12y squared. So this array does work, and I wind up with x minus 6y, x plus 2y. Okay, and we're factored. Okay, a couple more examples here. I'd like you to try these two on your own, D and E, and when you're finished, push play and we'll go through the answers together. Okay, so you can take a look and check your answers here. Let's just run through them together though. So what I imagine a lot of you did was expand out x plus 3 all squared. Now, be very careful when you're doing that. This is not equal to x squared plus 9. If you're expanding x plus 3 all squared, it's the same thing as x plus 3 times x plus 3, and we expand that using an array. Okay, so that's what I did down here with this first giant array here. I had x plus 3 times x plus 3, filled in my array with multiplication, so I wound up with x squared plus 6x plus 9, and that minus 36 just carried down. So once I collected my like terms, I got x squared plus 6x minus 27. Once that finished, what's here is what we call a simple trinomial because the a value here is 1. When I threw that into my array, I'm looking for two numbers that multiply to negative 27, but added to 6. So that was 9 and negative 3, and I get x plus 9, x minus 3. Okay, there is another way of doing this that might be a little bit faster. So I'm just going to quickly show you this on another slide here. So what makes this a bit more complicated to work with is the presence of this x plus 3 all squared. So it would be nice if it wasn't there. So why don't we actually just replace the x plus 3 all squared with a different variable. Let's just say let's say a. So let a be equal to x plus 3. Okay, and that's something we're allowed to do. So if I do that, instead of x plus 3, I have a, so I wind up with a squared minus 36. Okay, now you can probably agree that what I have here is much, much nicer to try and factor than what I started with up here. A squared minus 36 is a difference of squares, so it factors into a minus 6, a plus 6. Okay, and we're almost done now, except now I have to actually, I kind of cheated here getting rid of the x plus 3, replacing it with a. Well, I can't get away with the cheating forever, right? Down at the final end, I have to replace the a value with the x plus 3 I originally replaced a with. So everywhere I see a, I'm going to replace with x plus 3, so I wind up with x plus 3 minus 6. And then this a, again, becomes x plus 3, so I get x plus 3 plus 6. Okay, which one again once I simplify inside the brackets, 3 minus 6 is negative 3, so I get x minus 3. X plus 3 plus 6 is x plus 9. So I end up with the exact same thing I did before, but potentially having it go a little bit faster. Yeah, just keep that in mind. Always look for faster ways if you can do it. Now, for E, I threw it into an array because why not? It's always worth a shot. So I put m to the fourth in the top left, 5 in the bottom right. The only thing that multiplies to m squared, or m to the exponent 4 is m squared times m squared. Now, I could try m cubed and m, but that would involve other terms in here, which I don't want. So m squared times m squared is what works. So what two numbers multiply to 5, add to 6, going to be 5 and 1. But when I multiply 3, I'm going to get 5m squared and m squared because I need them to add to 6m squared. So this whole thing factors into m squared plus m squared plus 5 and m squared plus 1. Alright, and last but not least, two relatively quick ones to do. So looking at f, what you should always do first and foremost, look for a greatest common factor. So if I take out a factor of 2 here, I get x squared plus 6x plus 1. Okay, what's left over here is what we call a simple trinomial. So I would need two numbers that multiply to 1 and add to 6. Okay, so hopefully you can't find me a pair of numbers that works because this one's actually impossible. So one way you can tell here, the only option that multiply to 1 would be 1 and 1, or negative 1 and negative 1. None of those are going to add to 6, so this does not factor any further, so I would have to stop right here. Okay, so unfortunately that happens sometimes, not everything's factorable. We're going to have ways of dealing with ones like this coming up later in the course, but right now we can't take it any further beyond taking out the GCF, or greatest common factor. Okay, and G, we've already seen ones like it. We had t squared plus 4 in an earlier example when we were trying to factor it. Here we have x squared plus 4, same thing, different variable. I would need two numbers here that multiply to positive 4 and add to 0, and again, that is just not possible. So this one does not factor. Alright, so that's it, that's all. So at this point here, you should be making sure that anything I've assigned either in class or from the textbook or from worksheets for homework is finished. Okay, so factoring is a very important skill. You need to develop speed at it, not just accuracy, but speed. So please make sure you complete all that homework so you're in a good shape going towards the quiz and the test. Okay, that's it.